Hey Math 8, today we are doing lesson 4.5, which is comparing properties of functions. So yeah, let's just go ahead and get right into it. We're going to be looking at, for example, 1. We've talked a little bit about how functions can be represented in several different ways. You have tables, graphs, equations, all sorts of things that we've really looked at. So this is kind of an example of how we can compare two different types to get the information that we need. All right, so for example, 1, it says a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of a zebra. Compare their speeds. Okay, so we see right away the graph here is going to be our speed for a zebra. All right, while what we're told here is the speed of a lion. All right, so in order to compare their speeds for this example, what we need to do is we need to find the rate of change for both the equation, both the written words that they give us and the graph that they give us. Okay, so as a reminder, rate of change is another way of saying slope. All right, so they already tell us in the words that the speed is 53 feet per second for a lion. Okay, but we need to find for a zebra. Okay, so with a zebra, we can look at the graph. All right, and we can find the points that they have here and use our slope formula. Okay, so as a reminder, slope formula is m equals y2 minus y1 over x2 minus x1. All right, so then when we go in and we try to do it ourselves, we're just going to pick 2 points. So we can pick the point 159 right here and the point 118 right here. Okay, I'm then going to use my y values and my x values to do this. So I'm going to use 118 minus 59 over x2, which is 2, and x1, which is 1. All right, and I'm just going to simplify this. So 118 minus 59 is 59, and then 2 minus 1 is 1. So our slope is 59. Okay, so that tells us that 59 is our zebra's speed. Okay, so if we look at their speeds, all it says for this is to compare their speeds. So basically that tells us a lion can go 53 feet per second, while a zebra can go 59 feet per second. So I don't know if you knew this, but apparently zebras are faster than lions. So yeah, that's kind of neat. All right, and then we will go ahead and move on. Go ahead and try out Got It Problem A on your own, and then we'll move on after that. All right, so if we look at example 2 now, on the next page, it says the function m equals 140h, where m is the miles traveled in h hours, represents the distance traveled of the first Japanese high-speed train. The distance traveled of a high-speed train operating today in China is shown in the table. Assume the relationship between the two quantities is linear. Okay, so step A, it says compare the functions y-intercepts and rates of change. All right, the y-intercepts for both of them are going to be 0. Okay, we can see that here. There's no b. Okay, there's no, if we look at y equals mx plus b, you can see there is no b in this equation, which means there's no y-intercept. All right. The other side of this is on the table. We can see down here they show us the rates of change. Okay, so they go up 217 each time, which means the first time they go up 217 as well. Whoops, 217. So in order to get to 217, by going up by 217, they have to be at 0 to begin with. Okay, so that tells us that they are both direct variations all right, which means they have a y-intercept of 0 for both of them. Okay. All right, so then they look at the rates of change. Okay, so rate of change is the same thing as slope. So that means the rate of change for the Japanese train is 140, and the rate of change for the Chinese train would be 217, as you see down here. Okay. And yeah, that's pretty much it for that. And then if we look at B, it says if you ride each train for 5 hours, how far will you travel on each? Okay, so the way to do that would be to go ahead. For the Japanese one, it's pretty easy. We just do m times 140h, and then we plug in 5 for 5 hours, okay, which would be our h. Okay, and that will give us m equals 700. So you will travel 700 miles in 5 hours on the older Japanese train. And on the newer Chinese train, you could do it in a table like this. I think your best bet is to just create another equation, but this time it will be m equals 217 times h. Okay, the reason is that is our rate of change this time. Okay, so now we have m equals 217 times 5. All right, and if you plug that into your calculator, you're going to end up getting 1,085 miles in 5 hours, okay, which is, as you can see, a lot further than 700 miles. Okay, so those trains have really sped up quite a bit since then, which is pretty cool as well. All right, so that is it for example 2. Okay, go ahead and try out Got It problem C. I'm not going to have you worry about B, but go ahead and do problem C, see if you can figure that one out. Okay, the final example that we're going to look at is example 4 on page 313. Okay, so this one says Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table and the graph. Okay, which company should she use to rent the truck for 40 miles? All right, so we've got Crosstown Movers and we've got Ron's Rentals for our 2 rental companies here. Okay, so the first thing that we're going to want to do, I would personally suggest making an equation. Okay, the other option here, which is also a pretty good one for this one, is to go ahead and just extend this table, and you'll go ahead and get it. So we go plus 10 again right here and plus 25 again. The reason I knew to do that is because that's what's happening here and here and then here and here. Okay, so yeah, we'll get to 40 and 100, and I'm going to rewrite that because that was pretty ugly. There, at least now you can easily see what the numbers are. So yeah, yeah, that's going to be our cost for 40 miles on the table or from Ron's Rentals. Okay, our other option is to, for our other one, for our graph, we're going to want to look at the line, and we'll need to look at our equation and our slope. Okay, so as we look at Crosstown Movers, we have the first thing, so our equation we're going to want to be in slope-intercept form, so y equals mx plus b. And then we know that our y-intercept is 30 because we can see it right here, right? So we can go ahead and put that into our equation, y equals mx plus 30. All right, and now in order to find the rest of the equation, we just need to find our slope. The good news is they give us 2 points right here and right here. So we can plug it into the slope formula. So we'll have m equals y2 minus y1 over x2 minus x1. All right, 45 minus 35 is 10. 30 minus 10 is 20. 10 over 20 is the same thing as 1/2. So our final equation for crosstown movers will be y equals 1/2 x plus 30. Okay. So we have that equation. And then the last thing that we need to do is we need to find out, remember, we're still looking at 40 miles. So we got to plug in 40 for x because x is our miles. Okay. So we have y equals 1/2 times 40 instead of x plus 30. Now we just need to solve for y. So we're going to simplify. 1/2 times 40 is 20. And then 20 plus 30 will give us 50. All right. So the company was, which company should she use to rent the truck for 40 miles? Well, if she does Ron's Rentals, she's going to spend $100. But if she does Crosstown Movers, she'll only spend $50. All right. So in the end, she's going to want to find, or she's going to want to use Crosstown Movers for this job since it's 40 miles. All right. And that is just about it for this video. So yeah, hopefully it went well. Hopefully you took good notes. Make sure you've got all this down. If you don't, ask me questions, and then I will see you guys in class.